Good morning, everyone. My name is Stephen Roth, and I am the president of Carmel Software and also on the board of Green Building XML. Today's webinar is titled New Building Analysis Software Tools and Green Building XML. So the agenda for today is I will be presenting an overview of Green Building XML and talking about some ongoing initiatives that we are doing. And then I'll conclude with questions and answers if we do have time. And then after my overview, I will be passing the webinar over to Jim Spielbauer of Trane Technologies, who will be demoing the updated Trane TRACE 3D Plus desktop software that uses gbXML. Then after Jim's presentation, Ben Welly of Perkins and Will will be demoing the new Speed web and cloud-based software tool that also uses gbXML. So before we continue, I'd like to do a quick poll. And here it is. What type of professional are you? Okay, I'll close the poll, and it looks like, let me share that poll if I can. Okay, so we have about 35% of you are energy modelers, and 21% are software designers, 19% are architects, and 22% are engineers, and other 3%. So looks like we have a nice variety of people out there, which is great. All right, so I'd like to give an overview of gbXML. So obviously, if you're attending this webinar, you know what it is, but there's always new people entering the industry. So I'd like to give an overview of exactly what it is so you really have a good understanding of it. So I like to say that gbXML, or Green Building XML, is the language of buildings, and it allows disparate building design software tools to all communicate with one another. So building information modeling, or BIM, and gbXML are complementary to one another. The whole essence of BIM is interoperability. So getting the data out of the BIM into other tools that can utilize that data. And think of gbXML as the transport mechanism that allows this data to flow from BIM to external software tools and back. So gbXML is not a programming language, and is also not a software tool. It's a structured XML schema or language that focuses on storing data about buildings. Now, this is all in the name of helping architects, engineers, energy modelers, basically all of you out there, to design more energy efficient buildings. So what type of data is gbXML able to model? Well, gbXML has over 500 different types of elements, attributes, and enumerations that describe all aspects of a building for purposes of analysis. And what you see on your screen here is just a subset of some of the elements in gbXML, including 3D planar geometry, opaque construction materials, thermal and emission properties, HVAC equipment, glazing, and much, much more. Now, the real power behind gbXML is its geometric elements, basically allowing tools to draw a schematic or analytical view of the building for purposes of importing into analysis tools or viewing on the web. gbXML is lightweight, so it only has the information required by these tools, so it's fast and efficient. The types of analysis that gbXML excels at includes what you see on the screen here: whole building energy analysis, heating and cooling loads, renewable energy, lighting, CFD, and more. In fact, software tools currently exist that cover all these types of analysis, and they also all integrate with gbXML. So let's talk a little bit about ownership and support of gbXML. So gbXML is open source schema, and it's available at gbxml.org. Also, it's available on GitHub at the Green Building XML repo. gbxml.org includes a board of directors comprised of 11 BIM authoring and building analysis software vendors worldwide. We have 54 software applications that support gbXML currently, and more come online every couple months. And this year, happens to be the 20th anniversary of gbXML. It was actually founded and created back in the year 2000. Now, a number of research projects are currently focused on improving the gbXML workflow, and I'm going to talk about one of those briefly. Then also, we have this free online gbXML viewer that is regularly being updated, and I will also talk about that for a minute or so before our presentations. So let me talk about one of the research projects that is occurring. It's being conducted by a vendor for ASHRAE, the American Society of Heating, Refrigeration, Air Conditioning Engineers, and the name of this research project is Development of Reference BIM Test Cases for Improving Usage of Software Interoperability Schemas. It's quite a mouthful. However, the overall objective of this research project is to develop 20 or more geometric test cases for BIM software tool vendors to utilize to help their tools successfully export valid gbXML that can be used by building performance software. So this research project will also create an open source web-based validation software tool that allows these software vendors, to upload their test cases, view the gbXML models in a web browser, and receive detailed reports. So we've interviewed stakeholders, including energy modelers, and asked them what were their pain points when trying to transfer building data from their preferred BIM authoring tool to a building analysis tool. And we came up with some of these simple building geometries that you see on your screen here. So one example of a test case is this one, a roof with an extended overhang. And basically, typically a roof will have overhangs for various functions, such as roof ventilation or rainwater controls, and overhangs also provide shading to the walls underneath them. So therefore, it's critical to model overhangs in performance analysis. This test case demonstrates how overhang can be modeled in gbXML, as well as helps the BIM authoring tool vendor to test the gbXML export function regarding roof overhangs. So this is just one example of a test case. And a test case will include not only documentation, but a sample gbXML file, sample Revit file, and other types of files. So let's talk a bit about the viewer. So many of you may know about this free web-based gbXML viewer that's available at gbxml.org. Just go to the website in the upper right, you'll see viewer link. It's been out for actually a couple years, and we're constantly updating and improving it. So the current version allows you to upload gbXML files, view them in your browsers, pan, zoom, explode views, and view issues with the model. You can even edit the file. You can view it on your desktop, on your smartphone, and your tablet. So let me show you a brief example of our current gbXML viewer. This is, like I said, available at gbxml.org. And this is a fairly large model that's in my browser. And as you can see, I'm able to rotate, zoom, and then there's also lots of other features here on the left that allows you to query individual elements, and you can also view issues with the model and even fix the model. So this is the current viewer. Let me show you a beta of our next version of the viewer, which is what you can see on the screen here. And this is the same model. This is in a little cleaner user interface, and it will have the same functionality as the current viewer that's available, but it will also be much better performance and additional features. So this is kind of a sample of our next version of the viewer. All right, so before we continue into the presentations, I want to do another poll. What type of BIM or design software do you use? Okay, so the results of that poll are 19% using licensed BIM software, open source 26%, licensed building analysis 18, and then one or more of the above 36. So about what I expected. All right, so let's start with our presentation. So first of all, I would like to introduce Jim Spielbauer. He is the lead engineer in the modeling and simulation group at Trane Technologies. Jim joined Trane in 1992 and has been a member of the TRACE 3D Plus development team for the past 7 years, where he focuses on cloud computing, building geometry, and gbXML features of the software. So I'm going to hand the webinar over to Jim to demo Trane TRACE 3D Plus.
Thank you, Stephen. Are you able to see my screen okay?
Yes.
Okay. What I'd like to cover today in the next 20 minutes or so is a high-level overview of TRACE 3D Plus for those of you on the call that may not know or be familiar with the software. And then I'd like to cover, I have a slide on a workflow that I as a software developer use as I've been working on the gbXML import feature of TRACE 3D Plus and continue to work on improving it. And then I want to jump into a demo where I have a Revit file and export from Revit and then import into TRACE and run a simulation. And then if there's time, I'd like to take a look at some of the challenges with gbXML that I've been seeing over the last couple of months and see if we can talk a little bit about those as well. So TRACE 3D Plus is a building design and analysis software. Its predecessor was TRACE 700. 3D Plus is built on top of the Energy Plus calculation engine. One of the big differences between TRACE 700 and 3D Plus is that you can see 2D and 3D views of your building in TRACE 3D Plus. People use it to do comprehensive energy modeling and economic analysis. Like 700, 3D Plus ships with a bunch of libraries for easily creating room types and assigning loads and constructions to those buildings based on the type of building that it is. And I'll show some of this in the demo. Then you can schematically configure systems and plants. And then the area that I kind of want to focus on today is there's three different ways to create your buildings, geometry in TRACE 3D Plus. What you see on the screen here is probably the most common use today. People will import a floor plan image and then trace their rooms over the top of it. Another way is to use the building wizard, which is for early conceptual design where you can create common building shapes and then do a core and perimeter analysis of that building. And then the third way, the way that I want to demonstrate today, is to create the building geometry by importing it from a gbXML file. Before I get into the demo, I just kind of want to talk about some of the things that I've found useful as I've worked with gbXML. And I think one of the key things to recognize is that as much, I think, as the industry wishes gbXML was the easy button, we're not really there yet. But there's some really good documentation out there. A coworker of mine, Joshua, put together a very nice user's guide that helps walk people through some of the steps that they need to follow in order to create a good analytical model from the architectural model. And then Autodesk has some very good documentation as well. They'll talk about, ceiling plenums and making things room bounding and columns and a lot of the things that can maybe inhibit or not make the gbXML go as smoothly, on the first pass. So it's really important to kind of understand that documentation and what it takes to create an analytical model that's going to be able to be imported in some of the tools that are out there that consume gbXML, such as TRACE. One of the big improvements of TRACE 3D Plus when we came out with version 2, I guess, with version 1, I would say that the requirement was that the geometry had to be watertight. And that was sort of an unrealistic expectation. And with version 2, I guess the way I would describe it is that TRACE reads the gbXML data and sort of massages it into the TRACE 3D Plus data model and then it creates your rooms using that data sort of as if the user had drawn them. And so that has really helped improve Trace's ability to import gbXML. And I kind of glossed over that the high level bullet. You know, one of the things I would recommend to people as they start going down this path is, you know, don't start with a 500 room example and expect to hit export from Revit and have it just import right away. You know, maybe start with a couple of room example, work with your architect, and try to figure out what works. And you know, each architect is a little different. Each building model in Revit's probably a little different, and so the steps that might work on one model may not always work on every model. But you should be able to use the guides that I reference up above and create an analytical model that should import. And then, you know, Stephen already mentioned Ladybug Spider, and you know, I use that all the time when I'm looking at gbXML files and trying to make Trace more robust in its ability to import gbXML that maybe isn't the best. So, you know, go take a look at the XML file and see if it looks reasonable. And the Spider renders different surfaces in different colors, and those colors mean things. And you can use those colors to make sure that the boundary conditions of the surfaces are what you in fact need them to be. And then I'll demonstrate, there's this issues feature, which you can run on the gbXML, and it'll sort of highlight things that it thinks might be problems in the gbXML. Now, just because Spider, you know, flags it as maybe a potential problem, that doesn't necessarily mean that file won't import into Trace 3D Plus. But if you are having problems, that might point you to some things that you might want to check and try to improve in your model. And I guess the last point I'd like to recommend is that, you know, once it does import, you probably want to go through and just quickly do the minimum you have to in order to be able to run an analysis to make sure that, yes, the geometry came in, but are there anything wrong with it that's going to prevent it from simulating, you know, later on. And so I'd kind of hate to see you go through the whole effort of assigning room types and zoning your building only to get to the calculate step and then find out there's something wrong with the geometry. So with that, I'd like to jump into the demonstration. So this file that you see is one that ships with Revit. And my coworker Joshua went through and followed the steps in that guide that he wrote for working with Revit files and getting them to import into Trace. I don't really have time on this demo to demonstrate all the steps, but one of the big ones is making sure that things that should be room bounding are room bounding, and those things that you don't need to be room bounding aren't. And so, for example, you know, if we go to say a level view, a lot of times I'll see buildings that people try to import and they'll have structural columns and they will have left them room bounding. So, you know, Revit has some very powerful tools for changing that. So you can come into your model and, you know, select all instances in the entire project. And if, you know, now Joshua has already made the columns not room bounding, but had they been room bounding, you just need to uncheck this box. And so there's effort involved with taking the architectural model and making it into an analytical model that you can then export and import into Trace. So the next step, once you go through and try to get a good analytical model, is to export it. And you need to be on the 3D view of the building in order to export. And you would come up under File, Export, gbXML. And I think there's 3 different ways in Revit to export gbXML. The one that we recommend you use and are most familiar with is the room and space volume method. And then when I get into Trace, I'll talk a little bit more about this, but right now we are only importing the building geometry. So things like building type and location, where gbXML import is in Trace, you've already answered these questions. So we're not really using any of that data from the XML file at this point. So then you can also use this viewer and get a view of what the gbXML sort of looks like. And you can click next, and then you would save your file. So now it's going through and creating the XML file. And then when that's done, we'll go take a look at it in Spider. So now this is the tool that Stephen had referenced before. So then you would come under here and you can say choose file. And let's go grab that XML file. Maybe I had this open too long. Sorry about this. I don't know what happened. Maybe I had Chrome open too long. Try again. So let's choose the file. Okay, good, it imported. So you can take a look at your file. You know, we can see that all the floor slabs are there. Sometimes I'll see buildings that have absolutely no floors. I don't quite know what causes that, if maybe they didn't set the floor to room bounding. Sometimes there'll be gbXML files that don't have any roofs, but this one looks really good. So if this looks like a good representation of your building, then you know we can move on to the next step. I did want to show the feature that I do use a lot is this fixer menu. There's this feature called Run All Checks. And again, not that everything that this finds, you know, may not mean that the file won't import. It's just things to be aware of. And like I mentioned earlier, this one about non-watertight spaces, this would have been a problem in Trace v1. It's not really a problem anymore with v2. So now let's jump over to Trace itself. So I've got Trace started here. So we're going to create a project. And like I mentioned before, where the gbXML import is, you're already defining your weather location. You're setting up some of the defaults from geometry. So then you come to your select theme screen. I had mentioned, you know, we have a whole bunch of different building types. And with these building types will come in a bunch of the templates used for loads and other properties such as constructions. So this was sort of like a medium office. Here's a bunch of the different room types that the theme contains for a medium office. So now it's pulling all that data into your project and adding it to the tree. Okay, so now it brings us into the weather location, which we've already set, but if you wanted to, you could come in here and change it. And so then we come to the create building screen. And as I mentioned earlier, there's the ability to create a building with this building wizard, or you could draw a building. But here's where the import gbXML is. And so then we would go grab that gbXML file that I exported. Now the code is kind of going through and reading that gbXML file and trying to interpret it and map it to the trace data model. If there are things it finds that we don't quite understand, it will try to mend it. Some of the things that I've seen in other XML files are interior walls that are sort of flagged as ground contact, or exterior walls that are air walls. But this file is in a pretty decent shape, and so there's nothing that it really finds as errors. If there were errors, then the file won't come in, and you would need to go back and try to correct those things. The warnings are more things that it found that, like I mentioned before, that maybe it doesn't quite understand or that look suspicious. So those also might be things that you might want to go back and take a look at and see if you need to make any corrections. Then you can close this. And now it's going to go load all those rooms. And so now we can see a 2D view of your level 0 of your building. The import uses the name that's assigned to the space in the XML file. If the name is provided, the name field is an optional field. If the name field isn't provided, then it'll use the ID of the space, and the ID is a required field. So now we can kind of take a look at the building. Turn on some sun here to get a little shade. But here's that building that we saw in Revit. And it seems like a pretty good representation. Everything seems to have come in. So then the next step, that last step, I said, okay, so the geometry came in, but what you really want to do is convince yourself that yes, it'll calculate okay. So the quickest way to do that would be to come in and just auto assign all your rooms to zones, which may not be realistic, but again, this is just to convince yourself that yes, it came in and you can calculate. Then we would come under systems. And the simplest system to use, I think would be just a, VAV reheat DX system, because then you don't have to go through and assign any plants or plant loops or anything like that. And then you need to assign all those zones to the system. And again, this isn't intended to be a realistic example. It's just intended to get to a point where you can run a simulation. So now we get to the summary screen. And if everything is got a green check mark, that should indicate that Trace understands everything and everything looks good to go. And then we can run a simulation. And this is going to take maybe a couple of minutes here to run. And I guess while that's going on, what I'd like to do is try to jump to Spider again. I'm sorry, I'm kind of switching gears here, but I want to make sure that I have a little bit of chance to talk about some of the challenges. And so here's a file that is a little bit more like what I'm seeing. You can see that there's, a bunch of gaps. I don't have access to, typically don't have access to the Revit file, so I don't really know if this is a reasonable representation of the building. I mentioned some of the things that you want to check when you're viewing your gbXML. Like I know that yellow means, it's an air surface, so that looks a little suspicious that we would have all these air surfaces sort of on the exterior of this building. Green is an interior wall. That looks a little suspicious. And then I think, yeah, over here, there's something going on here that doesn't quite look right. It looks like there's a door and a window or a wall sort of sticking into the door and something going on with this window. But this file, in fact, does import, and the code Trace 3D Plus is sort of able to interpret these things, and it makes its best estimate on what this building is supposed to be. So let's jump back and see where Trace is at. So it's about done.
Hey, Jim, you have another minute,
Yep.
and I do want to pass it on. So just to give you a heads up.
Okay, I'm at the end. It would just be to show that this in fact finishes and passes. So that's it, Stephen.
Okay, I didn't mean to rush you at the end, but we have about
That's
25
okay.
minutes left. Okay. All right. So thank you
Okay,
very much.
thank you.
Jim.
Yep.
All right. Thanks, Jim. That was great. I learned a lot actually about the new Trane TRACE. So really good to hear. So I do want to remind everyone that you are able to ask questions. There's a little question applet in the GoToWebinar. So feel free to ask questions, and if we have time at the end, we'll try to address them. If they're specifically for Ben or for Jim or for me, we'll try to ask the appropriate person. So feel free to ask questions. If we don't get to your question, we'll try to do it offline. All right, so let's continue with the webinar. So our next presenter is Ben Welly, and Ben is the Director of Energy Lab at Perkins and Will. He received a BS, a Bachelor of Science in Energy Engineering, and a Master's in Civil Environmental Engineering, Atmosphere Energy Engineering from Stanford, and an MS in Mechanical Engineering from the University of California, San Diego, and a PhD in Design, Construction, Integration, also from Stanford. So quite a pedigree there. He is a registered professional mechanical engineer in the state of California. So Ben will be presenting the new Speed software tool. So Ben, I'm going to hand it over to you.
Great. Can everyone hear me?
Yes, we can.
Great. Thanks everyone for joining. Happy to see a lot of familiar names joining this call today. Oops, share my screen. I'm going to go very quickly through just kind of an introduction to what I've been spending basically the past 4 years on at Perkins and Will, developing a web-based, cloud-based design and analysis platform for architects. So a very specific audience, which presents some very unique challenges. And then I'm going to kind of take a step back and show where we use gbXML in the workflow and how we would like to use gbXML moving forward in the workflow. And again, happy to answer any questions at the end, or you can get a hold of me afterwards. So our challenge is that at our firm, we, as a very traditional firm, distributed with globally with 3,600 architects, we only do energy modeling internally on projects on about, say, 3% of our projects. We rely on consultants to do that, and often they're not brought on till schematic design. And the goal for the firm is to have 100% projects doing that. So that was the charter back 4 years ago. And so I started thinking about how we could go about doing that and tackling a lot of the challenges that take place or that we would have to face along the way. you know, we knew it had to be web-based and cloud-based. If you want to install anything on a person's computer, forget it, they won't do it. We developed this platform, which has been released to the firm. I'm kind of going to cruise through a video, skipping some stuff here. We developed this platform, released it back October. It's gotten a fair bit of traction, but a lot of lessons learned in the process. So SPEED stands for the Simulation Platform for Energy Efficient Design. It does do daylighting simulation and solar simulation. Here are a number of the things that it does. You know, it was born out of research, but it had to be practice-based research. So we basically had to develop a platform that, what I like to say, balances simplicity with effective integrity. Architects want simple, but we needed the results to be accurate enough that they were reasonable to answer their design questions. And we needed a 24-hour turnaround. That's our constraint. From the time a question is asked between the project manager and a designer in the morning, they need to be able to go back and get some model-based analysis back to help answer that question in a meaningful way within 24 hours, or we make that decision and we move on. And so, you know, many of our consultants simply can't work on that timeline. So I'm just going to kind of show you some brief clips of different parts of the platform. Then I'm actually going to open up the platform and go into a little bit more detail and talk about the gbXML component. So we have a variety of ways to generate geometry. One is these pre-parameterized building forms, where you can quickly play with different topologies, different building shapes, etc. You can overlay it on Google Maps. We also have a block and stack tool built off the Floor Space app that NREL developed, Dan McCumber and others, and we customized it to make it more, you know, user-friendly for architects and added some additional functionality, particularly the 3D view. They must have the 3D view. Nice thing about this, it has the rules of energy modeling built in, so we know it's going to be a clean model coming out. Eventually, they want that CAD import at the end of the day, thinking it's the most useful. In reality, it's the least useful, but I digress. I'll talk about that in a second. This is the envelope page where you can quickly apply different fenestration systems. You can run shading analysis. You can run sun path analysis, and you can also run a radiance-based solar radiation sunlight hour analysis that has a dedicated 96-core Docker machine on AWS to run the calculations. And we came up with a new simulation method working with Zach Rogers and Rob Guglielmetti for that. HVAC's pretty simple, but I wanted to get it in there, so they started to understand the interplay of HVAC and envelope, and we use the HVAC measure for that. The tool is based on the premise of a parametric study, meaning you run a lot of simulations, and we wanted to do that so we could leverage statistical analysis and help understand the interaction of different design variables on others, rather than just have one simulation, you know, happen at the end. Whoops. And then we wanted to, we need to have highly visual and interactive results visualizations, you know, from bar charts to compare one or multiple designs, to introduce them to this concept of looking at all the runs in one chart, which is a very difficult thing to do, from, you know, parallel coordinate plots, 2D, 3D scatter plots are kind of the most basic ones, but still new for designers, so difficult to help them, to train them to how to use that to answer their design question. Statistical analysis allows us to look at the relative importance of design variables, multivariate regression, to understand the interdependencies between different design variables and outputs. We've applied it to about 65 projects that vary quite widely to date. Still tough to know exactly what the effectiveness of that was. You know, we gave them a platform to run this analysis. We don't actually know how they chose to use it in their design, in their decision-making process yet. We're in the process of trying to figure that out. But the next steps we wanted to, or the next set of features, well, first, this is just using daylighting inside 360 compared to speed. We wrote a custom radiance measure decoupled from the gem that resulted in quite a bit of savings. So a lot of new features we've envisioned for this project. You see up there gbXML import. A lot of different people have worked on this. A lot of you in this particular group will be familiar with Dan McCumber, Chincy Harriman, Teo. It's really been a large-scale collaborative effort over a very long period of time. And you know, a lot of lessons learned coming out of that. So I'm just going to open this up real quick and do a quick demo. So you log in via Okta. So right now this is still internal, although we're exploring opportunities to try to open this up for classes at universities or other people to demo and help vet the results and the process itself. So I'm going to create a new project here. And here I'm just going to use Google address API lookup. Here's where I am right now, Winona, Minnesota. With that address, we look up all sorts of information, climate zone, lat, longe, energy code, which brings in prescriptive requirements from NREL standards, etc. Based on the user login, here are a list of projects they have available to them. You can put some description, which is generally for just context. You have your unit system, primary ASHRAE building type. Here's a place to put in your benchmark UI based on architecture 2030 and target, what have you, to see in the visualizations later. And then geometry mode. So this GUI is pretty dynamic. It evolves based upon the selection that the user makes on some previous fields. And we did that to maintain the integrity of the statistical analysis moving forward. So there are 3 main modes that we envision. 2 are done, 1 is in progress. First one is parametric shapes. Here you kind of select, you know, are you comparing multiple footprint shapes, or do you know your footprint shape but want to compare multiple floors? And the intent of this is based on this selection, it changes the whole GUI downstream as you go through these pages on the left, and exposes, you know, limits certain inputs so that you cannot pick a variable for your parametric study that is not, you know, is not really valid from the viewpoint of integrity of statistical analysis. For example, if you look at multiple footprint shapes and you have a box and an H, you have way more zones in the H because we auto perimeter core. What if they put a data center in one of those zones just because they had an opportunity to assign more space types? The results from, you know, the sensitivity analysis could be telling you something about the fact that you have a higher equipment load, not about the building footprint shape. So here's where you define your shading buildings in parametric shape mode. I'll skip that. Everything is driven off, you know, what we think the designer knows in early design, hopefully square footage. So here, let's say it's a 200,000 square foot building. Here you can play with the number of floors, floor height. You can pick up to 4 massings. You can pick your different footprint shapes here, play with orientation. Here we have length and width. So everything is driven off length and width, and you can put all sorts of parametric relationships here. We just kind of picked one to start with. And I'm going to go to the next page. This is where we define the fenestration. So you can either define things for the whole building or by orientation. So if I zoom in here, kind of on the south facade here, and all these scenes are done in Three.js. So we can pick number of windows, we can pick the layout, 6 windows. The construction type, do you want overhangs or fins? Of course, you have different views, and you can view it with the Google Maps. You can do shadow analysis using Three.js light sources. I'm just going to expand this out. If you want to run sun path analysis, you can do that. If you want to run the radiance-based solar radiation or sunlight hour analysis, you can do so here. This should run pretty quick. We developed a new way to calculate, use radiance to calculate the incident solar radiation called the cumulative sky approach, which runs much faster than traditional methods without really much loss in accuracy. I worked with Zach Rogers on that. He claims it's more accurate, but I'm always wary of runs faster and more accurate claims. So I think we need more validation for that. But this is basically running on 96 cores. The custom script we have, this is a gbXML file converted to a radiance file. So we take the native Three.js geometry, convert that to a gbXML file, then to a radiance file. We pass that to a Dockerized AWS machine that has the script on it. We run it. It generates all the images for the visualizations, returns those images, and that's placed over the radiance file here in the scene for the user to view, and worked a lot with Teo in developing the prototypes for this. Obviously, the resolution you pick from grid sizing to, well, that's internal, from low, medium, high makes a big difference in the computational time, but this should be done in about 30 seconds, it's medium resolution. If the architect has to wait more than 5 minutes, they probably are not going to wait that long. So here we get the results back. These are all PNGs overlaid over the native radiance geometry with a legend. Eventually, we have the information here where we can just click on a point or a surface and get the actual value for that surface. That's not quite working now. You can export a gbXML file. If you want to bring that to another application, you can export a RAD file. So here, I'm just going to go. This is another viewer that Teo did. Nope. The cursor of the live demo. All right, so there's the RAD file. You can do the same with the gbXML file. I'm not going to go through the rest of the process just for the sake of time right now, but if I were to go back to here and click Block and Stack tool, this is where we have our custom floor space app, where you can pick up the 4 massings again. You start drawing your building geometry. You have a building tree here you can use. You can add spaces, different levels of snapping capability based upon zoom level. You can add a story here. Maybe you want to add a shading building. Oops. And this is passing a floor space JSON back and forth between this 3D viewer and the 2D view. Then you can assign your space types. Just for simplicity, just going to pick one here, and you do that. So we did our best to architect proof this, meaning if something needs to be filled out and it's not, it won't let you proceed, and I'll tell you how to proceed. So let's say that's my massing. Go to the envelope page, and then, whoops, that's interesting. Well, of course, this all worked about 5 minutes ago, but you can run the same type of shading analysis and radiance-based solar analysis. We don't have the gbXML or RAD export working for this yet. It's pretty easy to do, to convert a floor space JSON to that, so that'll be the next step. If I refresh this, go back here to project information. Of course, finally, we have gbXML import. We're planning on using Teo's Mavia or the latest version here, so the designer can finally import their geometry from the CAD application, and it'll be gbXML based, and they'd have the option to bring in windows or not. If they did not, they could use the functionality of the envelope page. But inherently, even if you automatically ran all the self-healing checks in the latest version, you're going to run into problems. And we have no standard way to develop Revit models. You see everything under the sun in terms of quality. And so our intuition was, given the fact that our designers simply will not read a 15 to 40 page PDF or a 45-minute video on how to prepare a clean model, they're just not going to, they're going to figure out real quickly that this functionality is not for them, and they'll revert back to the block and stack tool. So the question is, how do you, what are some possible solutions around that? I'm not going to go into current problems with this process. I know, when Jim talked about all the steps he was taking to ensure a clean file, our designers simply won't do that. And there's all sorts of challenges, from the unique geometry model, the BIM authoring application, to, of course, how you, deal with room separation lines, unconnected spaces, et cetera, et cetera. But the solution, at the end of the day, is going to require the user to go back and modify the BIM model, and they're just not going to do that. So one idea of how to make this happen: you eliminate fragmentation, you make it a web-based service, and you have a software architecture that allows for machine learning and artificial intelligence to be applied. Now, ignore the political and IP issues. I know they're significant, but there is precedence here for a system like this. Imagine this is up on the cloud and you have an API, and the user uploads their native BIM model. The reason we want the native BIM model, Revit, Rhino, what have you, is that, like Jim said, when you look at that gbXML file and you're trying to figure out how to fix it, or if that represents the actual geometry. Without that contextual native geometry, you don't know exactly how to self-heal it or if that is representative. If you have both, now you have the opportunity to apply AI and machine learning. And so you have multiple kind of methods to voxelize the model via spatial SDKs that each vendor would work with. And then that would generate the analytical model. Then you'd run your diagnostics, apply self-healing algorithms, then analyze those errors relative to the contextual native model to understand if those self-healing algorithms were correct, how to prevent those algorithms from having to be run in the future. Using, of course, you need some sort of ontology. Any kind of AI or machine learning system or architecture needs a certain structure. It needs a lot of data, a lot of models to work with. And the only way you can do that is by kind of crowdsourcing and pulling together everything that all the different vendors and receiving applications, models and challenges they've worked with, and those knowledge bases into one location. And then the receiving application, whether it's going back into Revit, say for Insight 360, or it's going into Trace or IS or Design Builder, they could extract their desired model view. And I know there's a few initiatives in the works right now to do this at various levels, but I believe that the time is right, particularly in this COVID environment where BIM authoring vendors are going to have a lot on their plate in terms of modifications and resource constraints they're going to face to accommodate kind of the new collaboration coordination environment that they're going to experience. And so you really would want all vendors, either CAD or receiving applications, to fund this, and you would open it up to industry and academia to leverage those knowledge bases for the machine learning components. What is the appropriate voxelization or other methods based on the native geometry model, et cetera. And I think you could have this purring in 1 to 2 years if you had buy-in. And I think this is, one problem that, vendors will be, of any type of application, would be happy to offload at some point. I think the value proposition is there now, both for users, CAD vendors, and any kind of receiving applications that use the file to have something like this. And that's it.
All right, thanks, Ben.
Yep.
All right, so we have about 5 minutes left, and we have actually a fair number of questions out there. So I do want to try to address some of them, and like I said, we're not going to be able to address all these, and we'll try to email you afterwards. But I'm going to pick and choose a couple of them and then ask our panelists to answer them. So, Jim, if you want to unmute yourself, there is one question for you here from Clark Denson. Jim mentioned a guide for preparing Revit models for import into Trace 3D Plus. Can you provide a location of where this can be found?
Sure. It's on the Trane website, and let me see if I can get a URL and paste it into the comment section.
Okay, that'd be great. All right, next question is for Ben. Ben, have you tested the platform's result against completed simulations in older projects regarding speed?
Yes, we have. So, we're in a continuous state of validation. Obviously, the more things you try to automate and make assumptions for, the greater the room for error in results. We continually go through a process of building up models in eQuest and taking other OSMs or DOE reference models or creating models in IES or Design Builder and comparing those results to our results and trying to calibrate that. It's a very tedious process. What we're trying to do now is automate that and basically take one of the stock QA/QC measures that NREL has, and working with NREL and PSD, Chris Balbuck, in basically encoding that process into the QA/QC process. So out of every time a project is run, we get a report that takes the results we get and compares it to a series of benchmark data, whether it's, right now it's based on the DOE reference model, but that's not always a good source of data benchmark it against. And so we want to have 4 or 5 different knowledge bases in there, so we can automatically start to identify, are these results reasonable, are they not, why might they be not, and where should we look to try to improve the process moving forward. One of our biggest challenges is the fact that we wanted to include HVAC in here. Obviously, you saw that we just have a drop-down menu that picks one system. So already, you're limited because you can't do multiple systems, and you have no control over perimeter core zone, or thermal zoning that system. Eventually, we'll have multiple modes, more than novice expert, but that energy modeler that has experience as an architect down to the mechanical engineer, expert modeler using a detailed application, and expose more functionality, if that seems to be one of the main kind of areas and challenges with data integrity. So right now we only use ASHRAE standard for prescriptive requirements. We want to get other energy codes in there. I'd say right now, probably about 60% of the time, we feel pretty good about the results. The rest of the time, we scratch our heads a little bit and we're not quite sure. And that's why we need to automate the process, because we built this to be a transparent box, not a black box. It's just a highly complex transparent box. And so tracking down the issues, whether it was an assumption and a schedule from an NREL standard down to we just happen to pick an HVAC system in the HVAC measure that doesn't lend itself well to auto zoning or selecting one per story or one per building. That's something that we're continually working on.
Okay, thanks, Ben. Another question for you, Ben, is some people are asking about getting an account on Speed, or whether it's going to be available to the public. What is the status of that?
So the status of that is we're kind of in the process of exploring opportunities for external funding to continue this project. I think it's grown beyond the research budget of Perkin and Will, and they're looking for opportunities, especially in this current environment, not to take the next step, which would be a full rewrite, a rewrite and a refactoring, which would kind of put them into the enterprise level software development, realm. But right now, by the end of this year, what we hope to do is have some version of this, or the whole version, available for students in classrooms and for other people to demo that have interest in it. So right now, I have the power to give people access to this, give them an Okta login. If you're interested, let me know. The time is now to kind of open it up to other people using it to start vetting it. We've been looking at it too long with the same set of eyes. The only challenge right now we have that I'm trying to get approval for is, it's fine if you want to run a couple projects with 50 runs, but if you want to run 10,000, we get that on the AWS bill, and the new head of IT who pays the bill won't be very happy about that. So we're just trying to work that out. And once we work out that issue, yes, we do plan to open this up to others, and maybe even explore a crowdsource funding mechanism moving forward, where it's freely available to people.
Great. All right. Thanks,
Stephen,
Ben. All right.
I did paste that URL in, but it says I can only send it to organizers and panelists. So I don't know if you can paste it into a place everyone can get it.
I'll try it right now. Okay, so I did include that URL. Hopefully everyone got that. Okay, so we are actually out of time, and I would like to thank both our presenters, Jim and Ben. That was great information on both of your tools. And I will be sending a link to a recording of this webinar to everyone who registered and attended this, so you will be able to rewatch that at your convenience. So this webinar is now over, and have a great day.
Thank you, everyone.
Thank you.